Hello and good morning, good afternoon, good evening, everybody. Thank you for joining. Hi, Chintan. How's it going?
Hey Alex, I am good. How are you?
I'm good. I'm good as well. Looking forward to this. So this is obviously second day of Road to Node. So we had a good run yesterday. I think I see a couple of familiar names in chat already. So that's good. That's good that people are coming back. So we had a great intro session with Priya yesterday. If you missed that, it's on our YouTube channel already. If you have registered for it, you will get an email in about 30 minutes or so. I think it's what it's scheduled for, with the content, slides and all. But yeah, today we are doing something else. We're doing basically not necessarily the next step. It's getting a little bit more complicated, I would say, but it's a different data set, different audience, different use case. A little bit. Before we dive in, though, I'd like, and I said this yesterday, and I'll say it today as well. Nodes is coming up. So Nodes is our online developer event, online conference, virtual, live on all the time zones. So what that does that mean is 24 hours live stream on the 16th and 17th of November. So no matter where you located, we will have something for you in the respective time zones. So that's the cool thing about it. So you don't have to, get up early or stay up late for some cool, interesting, engaging content throughout these 24 hours. So everybody, please register for it if you haven't done so already. This is no automatic registration. So if you registered for any of the workshops or all of the workshops, you are not automatically enrolled to Nodes. So you have to register for Nodes as well. A link is going to be in chat in a second. Where is it? Here it is. It is. Let me post that here as well. Here you go. Okay. So that's that. That's what I wanted to mention beforehand. And yeah, I think with that we are ready to go. We have Chintan on live on stage. We have Alexander Jarash, a colleague of mine, of ours, joining in behind the scenes. So if you have any questions, anything you'd like to ask in the Q&A panel on BigMarker, type it in there. We will have a look out for it. If for some reason the volume is a little bit too much for questions, please don't be mad or sad, and take your question to our community page. So there is community.neo4j.com. There is a Discord server as well. We will try to answer as many questions as possible. But if for some reason this is not happening today during this live stream, please take it to the community where lots of people are there active and will help with questions and problems, or if you just want to discuss things, this is the place to go, really. But yeah, with that, I think we are good to go. I'm handing it over to you, Chintan.
Yeah, sure. Thank you. And first of all, I would like to thank you so much, Alex, for setting this up and running the show so well. And also thanks to Alexander, the other colleague and the other people who are behind the scene and making sure to get this go well and get this go smoothly. So, hello everyone. My name is Chintan Desai. I am from Pune, India. I'm a programmer by heart and I'm into full stack application development. Currently, I'm working with Neo4j as a consulting engineer. So, today we will be discussing healthcare analytics using Neo4j as a part of the Road to Nodes program. And I would like to mention that I have a thunderstorm condition in my area, and hence, internet gods might pose some challenges during the session. If I lose connectivity by any chance, at any point, I will try to be back as soon as I can. And Alex and other colleagues who are together with me behind the scene, they will guide you on such case. In such case, hopefully, we have a smooth session. Also, when we are going through the presentation and working sessions, if you feel like we are going too fast or too slow, please let us know in the chat so that I can manage my speed accordingly. Okay. So some important points I would like to mention before we get started. So as Alex mentioned, this workshop is also being recorded. You will have access to this recording afterwards. There will be a hands-on session. So in this 2 hour time, we will be having a hands-on session. So you can just watch it or you can follow along with me. That would be great for you to have some hands-on. We will share a repository where you can get all the code and steps to perform all the hands-on. We will share the slides with you post these workshops so that you can use it for your reference. You can post your questions in the chat whenever you come across any question. I like to mention that I'll not be able to see the questions, but my colleagues will answer them. For if they are, I mean, they'll try to answer many of the questions. If there are a lot of questions, then we can take those questions and get back to you after some time. Any and for any further questions, you can definitely use the Neo4j community page or Neo4j Discord. Also, if you have any specific question or need any specific help, you can definitely reach out to me on LinkedIn. Alex will share my LinkedIn address as well as my Medium page address, so you can reach me out them at those points, and I would be happy to help. All right, so that was about the session important points, and now coming to the material source code. So we have already posted.
Chintan, sorry to interrupt, but are you sharing your screen?
Oh, sorry, I just forgot to share my screen. I'll do it right away.
That's no worries. I'll share your LinkedIn and your Medium blog
Yes,
in the
please.
meantime.
All right, thank you, Alex.
Here we go.
All right, so yeah, this was the slide that I missed while I was not sharing my screen. So this was my introduction part, and going to the important points about the workshop is being recorded and about the questions, where do you want to ask those questions. And now coming to the material and source code. So Alex, I hope my screen and the content on it is properly visible on the screen.
Yes, looks good.
All right.
Cool. And you had some
All right.
polls. You just ping me when you want me to run the polls.
Yes, I will
I'll
do
hit the
that.
button. Okay.
All right.
Cool.
Okay, so this is the material that we'll be using throughout the workshop, and we have already sent you the links of the AuraDB console in advance. So the Neo4j AuraDB is a fully managed database as a service offered by Neo4j. So with Aura, you don't need to worry about setting up the infrastructure and the software for your Neo4j DBMS, and with help of few clicks, you can just get your DB running, and it is in the cloud, and you just start using it without any hassle of managing the infrastructure beneath. So if you guys have already set up the Aura, that is great. If you were so busy like me, that's not an issue. We will set it up and we'll give it some time to come up and be ready for use. So in order to set up Aura, I'll just show you a quick process before we go further. So you need to go to the neo4j .com, and in the neo4j.com you see the get started link. So here you see a link of Neo4j AuraDB. So you click on that link and it takes you to the Aura console, and you can just say start free, and that takes you to a registration page if you are not registered. And if you are already registered, you just need to log in and you can say create a new instance, and it gives you an option to create a new instance. All right. And Yeah, so please note that it is important to set up a Neo4j version 4 instance for this workshop. If you have set up a Neo4j 5 instance, you can drop the same and create a new one with Neo4j version 4. Also, due to some technical snag, sometime people are getting Neo4j 5 instance by default on the Aura console, and they cannot switch to the version 4. We really apologize for the snag, and if you face this, we advise you to use the Neo4j sandbox. In order to use the Neo4j sandbox, it's the same process, just a little bit of diversion. So instead of going to the Neo4j AuraDB, you go to the Neo4j sandbox, and it takes you to the sandbox console. And from the sandbox console, again, you have to register yourself, or maybe log in if you are already registered, and then uh, you click on creating a new sandbox, and there are options to create a blank sandbox or a pre-filled sandbox. So I would prefer you create I would suggest you to create an empty sandbox, because we will be performing the data ingestion and data analytics both in this workshop. So I would suggest you to go for an empty sandbox. The sandbox is also the same experience. It is just that it's a developer playground, and it is a little slower than Aura, but we can take sufficient time for you to execute the queries if it is a little slower for you. So don't worry for that. All right. So let's create an Aura instance and wait. I mean, it will take some time to come up and be ready for your execution. So I would give everyone a minute so that everyone creates an Aura instance or a sandbox if there are any issues creating the Aura instance. And meanwhile, we will go through some other discussions around the use case. So I will just give a few seconds of time for everyone to set up their Aura instance and sandbox, and later I'll go to the next slide. Also, I mean, before we move to the next content, I have I mean, we have some polls on the session thread, like what is your role, what is your experience level with Neo4j and Cypher, and how do you think graph database is advantageous over other databases. So Alex, could you please drop those polls into the chat so that audience can give their answers. It is good that we understand the audience, and maybe we can flow our discussion afterwards accordingly. Alex, I hope I'm audible.
Yes, you are. I just dropped the first the poll into the webinar. So the question is, what's your experience level with Neo4j and Cypher?
Yeah,
And we can have that run for a bit
sure.
and see what people say.
Cool.
I can actually all run them all if you like.
Yeah, you can run them all,
Um,
and maybe after we go through the next content, I'll just collect the details from you.
Okay, sounds good.
Yep.
Then I'll run them all. They are all
All
open,
right.
so you all should see prompts for polls. If you like, you can participate and pick your answers. Would be nice
Yes.
to see some answers, and then we can look at those in a while. Mm-hmm.
Yes. Thanks, Alex. All right. So moving further, coming to the topic. So what is data analytics? So you guys must have heard about data analytics on a higher level. That analytics is a one of the trending topics nowadays, right? So on a broad level, data analytics is a process of analyzing raw data and to find out the trends and answer the questions and make data driven decisions. So today we will take an example of healthcare analytics. So there are majorly four types of data analytics when it comes to healthcare. The first one is descriptive analysis. So that is about what happened. So this technique summarizes the large data sets and describes the outcomes to the stakeholders. Uh, then comes the discovery analytics part or the diagnostics analytics part. So the diagnostics or the discovery analytics is about why things happened and determining what to explore next. So when you are exploring some data, you determine what we explored up to this level and what to explore next. Then comes the prescriptive analytics part. This technique helps answering the questions about what should be done using the and these when we answer questions in the prescriptive analytics, we generally take help of the data or the insights that we got from the above two, discovery and the descriptive analytics. So in the prescriptive analytics, by using the insights from the prescriptive analytics, data driven decisions can be made. So prescriptive analytics helps business to make informed decision in case of uncertainties. And the last one is the predictive analysis. This predictive analysis mostly rely on the machine learning strategies that can find patterns in large data sets, and uh, it can help predict what will happen in future, so that we can avoid some unforeseen scenarios coming to us and make data driven decisions based on the past trends and the analysis we made using the earlier analytics procedures. So In this example today, what we are going to discuss, that example touches the descriptive discovery and the prescriptive analysis to some extent. So we'll see it when we go through that example. So going further in this workshop, what will you learn? So you will learn applying a graph solution to a healthcare problem. First of all, this is an RDBMS data set that we are going to explore today, and we are going to apply a graph based solution to it. Think from a so you'll also learn to think from a graph perspective, thinking on uh, how to map the data model in graph. It is not always mapping the relational database tables directly to the graph entities. It always depends on what you need, what type of answers you need from the graph, and based on that you can prepare your graph data model. Also, you will learn to you learn to start with graph data modeling. We will also go through how we map the relational data model to a graph data model, and uh, after that you'll also learn about the data ingestion part. How do you ingest data into Neo4j from the flat files, and also querying with the Neo4j Cypher. And at the end, we'll be also covering the Bloom for visualization. So you learn how to use Bloom for visualizing the data that you have loaded into a graph database. So that is the overall content for you to learn from today's workshop. And yeah, I would mention it again. So if I'm going a little too fast or slow, please mention in the chat, and Alex will let me know so that I can adjust my speed accordingly. So before I go further, Alex, are there any answers from the polls that we ran?
Yes. So we had asked. Let me go here. We had asked, what is your experience level with Neo4j and Cypher? And we got about 100 responses to this, and 66 or 73% said you are a beginner.
Okay.
21% or 19 people said you are intermediate, and 7% or 6 people said you are an expert. So we
Cool.
have very much of a beginner's audience who are, I guess, new to the whole concept.
Cool.
What is your role? We asked as a next question. We got only 30 or so responses to this one, so maybe not as conclusive, but still I can read it out. Application development engineer said 30%, data scientist said 33%, and data engineer or architect said 24%. So I would say about roughly 30-30-30 split, with 10% product manager in there as well. And the other question was, how do you think graph database is advantaged over other databases? And we had over 100 responses to this one. And 28% said flexibility, agility, and performance. 48% said it helps leverage the connectedness of data through relationships. 14% said it's easy to learn and implement. And 10% says, I don't know it yet. So I guess that's honest answer for all the beginners who are exploring and looking for it.
Yes, yeah. I would like to thank everyone who answered. I mean, it helps us decide the further course of this discussion. So it's glad that many of you guys are new and beginner and want to learn more about the graph database and Neo4j. So I would hope we help you in understanding as much as we can make it possible from our side. All right, thanks, Alex. So moving to the next thing. So the data set that we are going to use today is the FDA's FAERS. So it's called FAERS database. What is FDA? So FDA is United States Food and Drug Administration. It's a federal agency of the Department of the Health and Human Services in the United States. And the FDA is basically responsible for protecting and promoting the public health through control and supervision of food and pharmaceutical products. And FDA has developed a system called FAERS. FAERS is basically a adverse event reporting system that they have in place, and it is used for post marketing safety and surveillance for all the approved drugs and therapeutic and biological products. So whatever pharmaceutical products the companies sell, FDA basically does a surveillance on all those drugs, and then it uses this system FAERS, the adverse event reporting system, to monitor for new adverse events and medication errors that might occur with these products. So if someone consumes a drug and he or she develops some kind of side effects with that drug, then the person or maybe the physician or someone can report that side effect to FDA. It's a computerized system, and anybody can report a side effect that is called an adverse event to FDA, and the adverse event is registered against the company who developed the drug. So it is basically a system to identify the correctable and preventable problems in healthcare delivery. So if there are some adverse event caused by some drugs, then they make sure that are the benefits of the drugs are more than the adverse event or not. If the benefits are more, if the ratio is, justifying that the benefits of the drugs are more, then they keep the drug running. Otherwise they kind of apply some do some kind of scrutiny on the drug and say, hey, this drug is causing so many side effects, so please justify how it does so, and maybe stop the drug for some time or so. So this is basically the use of the FDA's adverse event reporting system. And the reporting of adverse event can be done, it is basically a voluntary thing, but it can be done from the medical and healthcare professionals such as physicians or pharmacists, nurses and others, also by the consumers, like the people like us who actually consume the medicine. So anyone can report the adverse event to the FDA system. And not only adverse event, but some kind of medication errors are also reported to the FDA reporting system. Like if there is a problem in some measurement device that is provided with some drug, then that can also be reported uh, to F to the FAERS. So that is about the FDA FAERS. Now we will be using the FAERS data to perform graph-based analytics. So why we are using FAERS? So it is a good example of a relational database, and we will be using the relational database, and we will be mapping the relational database graph model to a graph model, and we'll be performing the analytics to see how the connected nature of the graph helps us performing some queries which are actually so difficult or complex in case of the relational databases and SQL, right? So we will be using the FAST data to perform graph-based analytics, as I said, and it is a healthcare industry database. However, this workshop is not intended for only healthcare industry audience. The technique and the workshop, the steps that we execute in the workshop will help you to develop a graph perspective first and foremost, and it will help you to be able to apply the learning in case of other applications also, not just the healthcare applications. So I'd like to mention, if someone is not coming from the healthcare industry, it is not that this workshop is not useful to you. You can definitely use the learnings from this workshop in any other application or any other industry area or any other problem statement, right? All right, so going next. So as I said, the FDA's FAIRS data model is a relational data model, and they have provided us with some CSV files for the tables in the database. So this is how the data model of the FAIRS database looks like. So there are 7 tables. So the demographic table is nothing but the case. The demographic about the person who developed the side effects, from which country the person is, and the age and sex and other details about the person. And the drug table contains the information about what drug was responsible for the side effect that the person developed. Then comes the table. So therapy table is basically whenever some person takes a drug, so the drug is generally prescribed by some healthcare professional or a doctor in form of a therapy. So in the therapy there can be one or more drugs, right? So this is the therapy table, for in part of as part of which therapy the drug was given or prescribed to the person. And this is the indication. So indication as in because of what, I mean, in order to subside what particular symptom the drug was prescribed. So this is the indication. Then comes the reaction table. So when the person consumes the drug and he or she develops a side effect, so what is the reaction that the person develops when he or she consumes the drug? And then this is the outcome table. So outcome is nothing but uh, what is the long term outcome. So after the person develops a side effect, in a long term, what was the outcome? Was the person had to be did the person have to be hospitalized for a longer time or a shorter time, or was it a death? That was the outcome of this. And the last one is the report source table. So the report source table is the person or the agency who reported this adverse event to the FAERS system. So this is the data model that the FAERS has. And you see that the primary ID is the primary key in all the tables, and it has the foreign key references from across the tables, right? So the primary ID is the column which is used to connect the records between multiple tables, right? So that was about the FAIRS data model. Now you must be thinking, why do we need a graph database to perform the analytics on this data? We can always query the table or data from a relational database, right? So let's imagine a scenario that you want to write a query to fetch below answer from the FDA data. Fetch details of a demographic case. So fetch details of a case that needs to be having age, sex, therapy that the person received, drugs prescribed under the therapy along with their dosages, adverse reactions, and outcomes caused by the drugs. And I mean, if you are able to write this query as a bonus, if you can extend the query to include the pharma company who registered the case and the report source who reported it, right? So from the thoughts only, it seems difficult, right? We need to join almost all the tables which are in the picture, and then perform the grouping and the aggregation to fetch the list of records and whatnot. So first of all, I'm not having any bias against RDBMS. I'm myself an relational database and SQL fan, and I have done a lot of SQL programming, and I do a lot of SQL programming in my day-to-day jobs. Just that the RDBMS has its own advantages in some problems like transaction logs and audit management and whatnot. But today we'll explore how we can leverage the connected nature of a graph database in a problem which is difficult to solve using an RDBMS. Okay, so I hope we are going good. And if you are again, if you guys are feeling like I'm going too fast or too slow, please let us know in the chat. And Alex, please let me know if there are any comments on the speed of the session. All right, so let's explore the graph. So in the graph, we what we'll do is we'll perform the data modeling, where we will analyze the FDA FAIRS model that we already saw, and we'll understand the Neo4j graph data model. Later, we will ingest the CSV data into Neo4j. Now, the FDA has some complexity and some master data to map the records and entries. So what we have done for you is we have got the CSVs, and we have massaged and cleaned the data to produce an easily understandable version, which we'll use for this workshop. We have also added the CSV files on the GitHub repo that Alex might have already shared, and you must be having it on your hand. So we have included the CSV files on the GitHub repo, and we will be referring the same CSV files from the GitHub URLs to load the data in using our Cypher queries. Later we'll fire some Cypher queries to perform some analytics, and at the end we'll use the Neo4j Bloom to uh, have a glimpse of visualization capabilities and its benefits in the analytics part. All right. Okay, so I will quickly move further to the next one. So the model that you are seeing on the screen, it has both the relational data model and the graph data model. right? So before I move ahead, I would like to ask Alex, is the model clearly visible on the screen, or is it, I mean, it needs to zoom out or zoom in?
Maybe if you can zoom in a little bit, that would be helpful.
Okay,
Uh,
let me try
if that is
to bring.
possible. But I think
Yeah,
in general it's visible.
yeah,
Yeah,
I will see if I can zoom in. Yeah.
I can maybe I can do something here as well. Maybe I move it like this.
Okay. So I am just focusing on the uh, I'm just focusing on the, yeah, graph relation data model now. And now let me know if it becomes a little better.
Yeah, I think it's better, and I zoomed in some more as well from our end, and I think
All right.
that's great.
Okay. All right. So coming to the model part, I hope the data model again, the data model diagram, which the relational database is visible as of now. So as I mentioned before, it is important to think how to map your data model in a graph, right? So it's not always like mapping the tables directly to the graph entities. Here we have some entities in the tables which are present in the graph database model also, but we have some extra entities or nodes in the graph. So it basically depends on what type of answers you want, or what you want, what content you want to produce out of the graph. Based on that, you can design your graph data model. So here you can see there are 7 tables in the relational database model: the drug, demographic, reaction, outcome, report sources, and therapy, right? uh, but in case of the graph data model, so we have a little different. I mean, some of them are coming from the tables, but some of them are different, some of them are additional, some we have just excluded, right? So I'll just explain how we came to this particular data model in the in the graph basically, right? So we have a demographic or a case. So this is the demographic information of a person who is involved in the adverse event. So he's a, if he is a male or female, and what's the age of the person, and what's the country where the person resides. So basically we have for this example, we have only captured the data from the United States, so the country should be United States in this. But yeah, it has all this information. And then comes the drug. So the drug is the drug or the medicine that was involved in the adverse event. A drug can be a primary suspect for the event, or a secondary suspect, or interacting or concomitant. So basically, if the drug is a primary suspect behind the adverse event, then we connect it using the relationship is primary suspect. If it is a secondary suspect, that I mean, sometimes we receive a couple of medicines as in the prescription, right? So the primary medicine is to reduce the primary symptom that we have, and then in order to reduce the acidity or the gas influxes and all, doctors give us some extra medicines which are basically there to reduce the side effects which are caused by the primary suspect, right? So this is the secondary suspect. And these are another two, like is concomitant and is interacting drugs. So these are the types of relationships ships that we have derived. And if you see in this model, in the drug, so it has the role code. So the role code is nothing but it shows whether it was a primary suspect, it was a secondary suspect, or it was a concomitant, or it was an interacting drug. So we have translated this in form of relationship. Then we have a reaction. So reaction is nothing but the side effect that a person has developed. Then comes the outcome. So the outcome is the long term outcome of the case after the adverse event happened. For example, it the patient need to be hospitalized for a longer or shorter duration, or maybe he or she developed a disability or death. So those are the outcomes from the adverse event. Then comes the report source. So report source is definitely, as per name, the one, the person or the organization or institute who reported the source. So the case reported by report source. And then comes the therapy. So the case received the therapy, and the therapy prescribes this particular drug. So the all the drugs that the patient was having, it was prescribed as a part of some therapy, right? Then comes the indication. So uh, in this data, you see the indication table separately. So the indication is nothing but why the patient was given a particular drug, what was the indication behind the or the reason behind the prescription of a particular drug, right? So we don't have the indication node in the graph database, you see. But I mean, since the Neo4j is basically uh, uh, a property graph model, and the relationships are the first class citizens in Neo4j. So we have got some of those properties of the indications in form of the relationship properties on these relationships, like primary suspect. So on this we have all those details, like the indication behind it and the dosage and everything, right? So this is where the indication lies. And then there's an age group. So in this data you don't see any age group table, but the demography has the age group number over here, right? So it has the age and the age group. So the age property of the patient or the case goes in as a property of the node. And we have also derived the age group as a separate node, because I mean, if we have the age group as a separate node, then we can perform some additional analytics that is based on the age group, like what were the side effects which were developed in case of children, what were the side effects which were developed in case of elderly or adult patients, right? So that's how we came across this that's how we came to this graph data model. So I hope I was able to explain how we derived this uh, graph data model from this relational data model. In the next exam, in the next slide, we'll go ahead and see it further, how it maps to an actual example, right? So going further to the actual example. So looking at the model, you can clearly see that the case, this is the case of an elderly. I'll again zoom in a bit. So yeah, so you can see that this is the case of an elderly person, and he's a male, and he was prescribed with this therapy, and the therapy prescribed these four drugs. These was the primary suspect, this was the secondary suspect, and this is again the secondary suspect, and this is the concomitant. And the case was reported by a healthcare professional. It is registered for a drug for the company Clegane. And then uh, the case had some reactions like anemia or a fusion, and then it resulted in an outcome that was other serious, I mean serious outcome. And it was a prolonged hospitalization that was the result of, or the outcome of this adverse event case, right? So this is how an actual example maps to the graph data model that we have created. We'll definitely go further, and we will ingest the data, and we'll see this graph data model and example working on some real data. But this is just to give you a glimpse of how you can think in how you can develop a graph perspective in order to perform the analytics, and in order to get some answers from a silo which is generally lying in the RDBMS in form of tables and the primary key and the foreign key. You need to develop a different perspective to develop a graph model in order to map your data correctly, and so that it helps you in producing the right amount of output and the right answers from your graph. All right, then I'm sure it must have looked interesting to you, and I won't take much time, and let's jump on the actual hands-on session. Will when we'll load this data into the graph, and we'll then learn to perform some queries on the loaded data. So I'll stop sharing the slides, and then I'll go to the working session time. So by the time, I'm hoping that all of you must have got your Neo4j Aura instance, or at least the sandbox instance, up and running. So if you have got the Neo4j Aura sandbox up and running, you just need to make sure that you are on the Neo4j version 4. And these are the buttons that are there. So in order to go to the Neo4j browser to perform the data ingestion and the query, we need to click on this button. And at the time of creating this instance, you must have got a password that you had to copy, or you might have downloaded the password. So if you click on the query button, so it opens the Neo4j browser, and then you need to apply the password that you must have downloaded at the time of setting up the Neo4j instance. So I'm applying my password and I'm saying connect, and it will log me into the Neo4j browser. So here I'm logged into the Neo4j browser, and on the left hand side panel, I see the database button. When I clicked on the database button, it showed me the default database Neo4j that is selected. Currently, I'm seeing no labels and relationships because my data is empty. Again, if you have got an empty database, that's perfect. If you have got a pre-filled database, or if you have done some playing around the instance, you can easily clean up the data in the Aura console. So in order to do the cleaning part, you just need to go to the console, and then you need to click on the reset to blank button. So it basically resets your database to blank, and it gives you a fresh copy where we'll be performing the data ingestion and the analytics thing. Right. And I mean, if some people faced an issue while setting up the Aura instance, or maybe they got a 5 Neo4j version 5 instance, and they are not able to go to the Neo4j 4, then you guys can easily have a Neo4j sandbox. The sandbox is the same process, just that it keeps running for 3 days, and if it expires, and if you want to have it for more days, you need to extend it. So this is the interface of the Neo4j sandbox. And here from the sandbox, you need to click on this arrow, and you need to say open the browser, and it will open a browser for that sandbox for you, and it will be ready for you to run your queries. All right. And if some of you guys are on the Neo4j sandbox, and it is a little slow than the Aura one, so we will go with the hands-on session in a little slow manner, so you can catch up, and we'll make sure that we give sufficient time for you to execute your queries and have your hands on. All right. So in the Neo4j browser from the sandbox, also I see the same thing. I see the Neo4j database and the system database, and there are no node labels and no relationship types here. So this is the empty database that I have on the sandbox. I will be performing my hands-on on the Neo4j Aura that I have got from here. But if you are not having the Aura, then you can use the sandbox. I leave it up to you. All right, so I'm again making sure that I'm opening the Neo4j Aura browser, and I have the password which I have copied in here. All right, so we have the Neo4j Aura browser, Neo4j Aura database, and the Neo4j browser running. So now going to the GitHub repo where we have the example. So Alex must have shared this link with you. So you just scroll down, and you get to see the data model, the example that we have captured, and you see a little bit down a link that is the unrendered guide, the documentation healthcare analytics. I will stay here, and I mean, give it a few seconds so that everybody can see where this link is. Or maybe Alex, you can drop in this link on the chat so that people can reach on the correct page. I'll just drop this link on the chat to Alex, and Alex can pass it to you.
Yeah, I put this in chat already.
All right. Thank you so much, Alex. So, yeah, this is the page where we have all the step by step documentation and the process that we'll be following in this today's workshop. So, you see the data model, and you see the entities in the graph nodes, which are explained over here. I'll not repeat them, and I'll come to the actual hands-on part. So in order to go ahead and ingest the data, as I said, we had our data model drawn. So once we have the data model, we have to define some constraints and indexes, so that when we ingest the data and when we query the data, it helps us identifying correct records using the unique indexes, unique constraints. And when we search for the records, the indexes actually helps us in searching through the records in fast fashion. and it gives us some performance advantage, right? So initially we prepare the schema. So you just scroll down to the schema part, and these are the queries. So I'll just grab these queries from here, and I'll just have it in the Neo4j browser. So just to understand these queries on a high level, so I'm creating the constraints. So these are the constraint name, and then it is if not exists, so basically it is just for the idempotence. If the index is already there, if the constraint is already there, then it will not create, otherwise it will create. And then I'm creating the constraint on a drug, and then I'm asserting that the name of the drug is unique, so that we do not have any duplicate entries for the drugs in the Neo4j database. So this is how I'm adding the constraints. And this is the syntax for adding the indexes. So if the index is not exist, then this is the name of the index that I'm specifying, and I'm creating it for the case and for the age, so that if I'm performing some search on the age property of the case, then it basically helps in that search query if the index is present. So these are the indexes which I'm creating on the case node. All of them are on the case node only: the age unit, gender, event date, and report date. And the constraints are on different nodes like drugs, case, reaction, report source, outcome, therapy, and manufacturer. Manufacturer is nothing but the company who is producing the drug. Okay, so I'll go ahead and execute this query. So you see all those index statements. So I just pasted all the index statements inside this query text in the query area as once, and it executed all the queries one by one. So the queries were separated by semicolon, and so it executed all the queries one by one, and I have my indexes and constraints created. Now if I go ahead and click on this button, so you see there are no node labels, but there are some nodes. There are some types of nodes which are being visible over here. So it is nothing but the clean the empty data model. So it just says you have a case label, you have a drug label, you have a manufacturer, outcome, reaction, report source, and therapy. And these are some property keys on which we have defined the constraints or the index, right? So now I have my database schema ready, and now I'll go ahead and load the data. So we will load the data step by step. So first I'll go and load the cases and manufacturers data. So I'll just take this query and then I'll put it here, and then I'll explain what this query does. Right. So this query is performing a load CSV, and it's saying load CSV with headers, and I'm giving this uh, demographics.csv file. So I will give you a glimpse of the demographics CSV file. It is there on my local machine. So this is the demographic.csv file. So it has a primary ID, an event date, and manufacturer name, age unit, year or months, age group, sex, report date, and the reporter occupation. Right. So these are all the details that we have in the demographics file, and I have uploaded the same file on the GitHub repo, and we are using it from here. So you don't have to change the file path or anything. You just need to execute the same query. All right. And what we are doing here, so we are using the merge statement. So merge is the Neo4j absurd statement. So similar to what we have in SQL. In SQL also we have merge, that if it finds the existing record, then it can update the record. Otherwise, if it does not find the record, then it creates the record. So conditionally, I have written that on merge, you merge this case on a primary id. You try to compare the primary id and find this case. And on create, if it is not present, then create and set this event date, report date, age, age unit, gender, and reporter occupation. All right, so I'm creating a case node, and I'm giving it a label case, and then I'm setting these properties on my case. And then next, I'm conditionally creating the manufacturer. So I'm saying manufacturer, and you identify the manufacturer using the manufacturer name. And then if it is not there, you create it. Or if it is already there, you don't perform any action on it. You just get a reference of that manufacturer. Then I'm just relating the case and manufacturer. So the manufacturer has registered a case. So you see the simplicity of the cipher here. So it's just the reference of the manufacturer, the reference of the case, and then the relationship type, which is mentioned over here. And the conditionally, we are creating the age group node and relating it with the case. So similar to what we did with manufacturer, we are creating an age group. So in the age group, I mean, when we are creating the age group, we are reading the age group property in the row, in the CSV row, and then we are creating a label or a node called age group that is having a label age group, and relate the case with the age group. So the C case falls under the age group A. So this is what the query is performing. It is creating a case, it is creating a manufacturer, it is creating a age group, and then it is linking the manufacturer with the case and the case with the age group. So I'll just go ahead and execute this query. So you can see that it has created 4307, more than 4000 nodes, and it has also created some relationship types. So you can see in the database information panel, there are 8614 relationships created by the queries that we executed, and there are 4448 nodes, or basically labels, which are created, right? So we loaded the case manufacturers and related them. Now we move ahead and load the outcomes and link them with cases. So this is the query that you can grab from here. The next query, you can just click on this button, it will copy it for you, and then you can paste it into the Neo4j queries pen. And then you see that we are using the outcome.csv file from here, and the outcome.csv file looks like this. So you see the primary ID, that is the primary ID of the case, and then what was the outcome. So there's a code for the outcome and there's a description for the outcome, so death, hospitalization, and then this is the data that we have for the outcome. So we are using the outcome file, and we are conditionally creating the outcome. So this conditionally creation is just because if you execute the query multiple times, it does not impact it, it does not create duplicate records. It just ensures that you have the right amount of records that you read from the CSV files, right? So you have the execute this query, it will create the outcome based on the outcome code, and then it will also find the case based on the primary ID. So we ingested the case details, the case data in the earlier query, and all the cases have the primary ID. So we match the case using the primary ID, and then we merge C resulted in outcome. So we merge this relationship so that it does not create duplicate relationships. If it finds the relationship already existing, then it does not do anything. If it is not, if it does not find the relationship existing between this particular outcome and the case, it will create a new relationship. So I'll go ahead and execute this query, and it will say, it says 4461 and labels are created. So it created the new outcomes, and it linked with the sources, with the cases. Moving further, we will load the reactions. So reactions are nothing but the side effects. So we will load the reactions and link them with the cases, that what cases, what patients developed what reactions. So we'll just put the query inside the query area, and this is, as you can see, the reaction.csv file, and it merges the reaction based on the description of the reaction. And the reaction is nothing but the description of the reaction, like hip fracture or pain or cough or diarrhea or memory impairment. So these are the reactions that this case is had. So we are ingesting the reaction data, and we are linking the reactions with the cases, like the primary ID. You find the reaction, the case with the primary ID, and then you create a reaction node, and then you link the reaction node with the particular case which had the reaction. So we'll execute this query, and you will see that it adds 21,000, somewhere near 21,000, 21,000 reactions to the database, and it has linked to the cases. So here in the relationship types pane, you can keep seeing that we have loaded the data, and we have the relationships like the falls under. So that is the case falls under what age group, what reaction does the case have, and then uh, the case was registered by what pharmaceutical company, and what was the outcome in which the case resulted. So this is the resulted in. Right. Going further, loading the report sources and linking them with cases. So report sources is nothing but the institutes or the healthcare professionals or the consumers who reported the cases. So I'll not go and show you the query, show you the file. I'm using the report sources CSV, and then I'm merging the report source based on the name of the report source, and then I am again finding the case based on the primary ID, and then I am merging the case and saying case reported by report source. So this is also a simple query. R is the report source, C is the case, and we are linking the C reported by R. So I'll execute this query, and it says I have created this many nodes, this many labels, and it has also added the reported by relationship, as you can see here. All right, now coming to the interesting part. So, loading the drugs and therapies. So, drugs and therapies are basically, as I showed you in the relational data model, the the drugs are basically having different roles when it comes to developing side effects when into some patient, right? The drug can be a primary suspect, the drug can be a secondary suspect, the drug can be a concomitant or an interacting drug. And also the therapy prescribes the drug, but the therapy has some dosage mentioned for the drug. The therapy has some start date and end date. Also the drug, when it is given to some patient, when the patient consumes the drug, there is a dosage, there's an amount of the drug that needs to be consumed, and also all those properties we are ingesting in form of relationship properties. So here I'll show you how we are ingesting the part uh, in the relationship, and how we are setting the relationship properties. So here you can see that I am taking the drugs and indication CSV. So I have combined the drugs and indication both into a single file. I'll just give you a glimpse of the file. So you see, this is the primary ID again. This is the drug sequence, so the sequence in each in which the drug was given, and the role of the drug, like primary suspect, secondary suspect, concomitant, and the name of the drug, and the primary substance in the drug, and the route. So what route the drug was given. So the route is either oral or intravenous, or and what is the dose amount that was given, what is the dose units, it's mg or mg per kg or g or some gram, or basically there are different units. And what was the indication, so why the drug was given. So sometime it is infection, sometime it is like plasma cell meloma. So these are different indications, right? So I am using the file. We are first what we are performing in the query. So focusing on the query, we are first creating the drug. So we are creating a label, a node for the drug, and we are giving it a label drug, and then we are setting the name. So the name in the drug is basically a unique name, and we have set a unique constraint on it. And on create, we set, whenever a drug is newly created, we set the primary substance property of the drug. Now once we ingest the drug, when we read the row from the CSV and we ingest the drug, we go ahead and we find out the case, that find out the patient who consumed this drug. So we find out the patient using the primary ID, and then we are doing this conditional part. So when the drug's role is primary suspect in the CSV, there's a column which has the role. When it is a primary suspect, then what we are doing is we are merging the C, the case, and we are giving it a relationship type primary suspect. So this is the relationship type that we are creating when the drug is a primary suspect in case of a side effect, right? And then the properties of the relationships are the drug sequence. So what is the sequence of this particular drug, what was the route, what is the dose amount, what is the dose unit, what is the indication why the drug was prescribed, right? And then same for the secondary suspect. we are setting the relationship type as a secondary suspect. So we are merging the case C with the drug D. And while setting the relationship, what we are doing is we are giving a relationship type is secondary suspect, and again we are setting all these properties. The properties are same, the relationship type is different based on the role of the drug, right? And similarly, we have is concomitant and we have is interacting. So this is how conditionally we create relationship between two nodes, a drug and a case, a patient, basically based on the type of role the drug has in case of developing the side effect. So I'll go ahead and execute this query. All right, so it added some labels, added nodes, and set these many properties. And you see the counts of the properties have increased in the database information panel also. Now, yeah, so there's only one part left for the ingestion. So there's only one query left. Let's load the therapy and link them with case and drugs. So therapies are basically the treatments which prescribed the given drugs, which actually develop side effects in the patients, right? So in this case, I'm using the therapy.csv file, and I'm creating the therapy node, giving it a label therapy, and the therapy has its own primary id again. So I am giving it a primary id identifier, and then once we find the therapy, we find the case by the primary id, and then we relate the case with therapy, that the case received therapy. Again, we are using the merge statement here so that it's an absurd. It does not create duplicate relationships if there were same records and we execute the query multiple times. All right, so this is how we link the therapies with the patients. And the next part is when there's a therapy, the therapy has some prescription of drugs, like one drug for this much amount, other drug for this much amount, and these many times in a day, right? So we relate the therapy and drugs. So we find the drugs using the drug name. So drug name is the unique identifier in case of a drug, and then we identify the drug using drug name, and then we relate the therapy, and then we say therapy prescribed this drug, and we have some properties in play in this prescribed relationship to identify the drug sequence again, the start year of the therapy and the end year of the therapy. So again, we have used the coalesce here. This is just to avoid and I mean just to take care of the situations when the start year or the end year is null. In the FDA's FARS data, FAERS data, there are some null records, and this is just to take care of those null records. I'm specifying 1900 and 2021 if there are null records. So I'll just go ahead and execute this query, and it added a few labels and created some nodes, set some properties, and then these many relationships were created, right? So yeah, I mean, we are done with ingestion of the data. I hope the ingestion part was uh, understandable. I mean, you were able to understand the ingestion part. If you have any questions, you can always post it in the chat, and uh, we can take a couple of minutes break, just for you to digest what we did so far. So just to give you a quick recap, we understood the FDA's adverse event database model. It is a relational database, and we had a look at what tables the model has in the relational database, and then we converted the relational database model to a graph database model, and we understood how you can convert basically how you can prepare a graph database model, in order to get necessary output or necessary results out of your graph, right? And then we started our Neo4j Aura or Neo4j Sandbox browser, and then we performed some data ingestion using the ciphers from the statements that we have on the repository. So basically, we loaded the cases, we loaded the manufacturing companies who manufactures the drugs, and then we ingested the drugs which develop the side effects to the patient for the patients, and then we ingested the report sources, we ingested the outcomes, we ingested therapies, and we also ingested the reactions, which are side effects. So we ingested all the data, and now we'll go ahead and perform the data analytics. So I'll explain you the analytics queries also step by step, and how we write Cypher in order to get results out of the Neo4j database. So we'll start with simple ciphers, and will down the line we go to some little and advanced ciphers. I'll make sure I try to explain each and every cipher and how it brings the data out of Neo4j. But if you have any questions, again, you can drop in the chat section, and my colleagues out there will try to help you with the answers. Okay, so we'll take a minute or a couple of minutes break. Alex, just wanted to make sure I was clearly audible and the screen was visible and the pace
Yep.
is good. Is there any comment regarding the pace?
No comment on the pace. I think so. We are good. A couple of questions that came repeatedly, maybe. So that's maybe something to we can have a look at. Is why is the age specified as a specific a separate node instead of a property? I mean, that's more or less. I would say, but maybe you want to answer this. But it's a modeling question, so you could do either way. I think both is a valid path
Okay.
to put it there. But people were wondering, was there a reason behind why age was a specific node instead of a property?
Sure, I will definitely take that question. So I'll show you the file, the demographic file that I have. So I'll just zoom the file a bit so that it is clearly visible. So you see there are two things here in the FDA's data. So there's an age and there's an age group. So we are not having age as a separate node. We are having age group as a separate node. So basically, when we say age, so if we have age as a separate node, then definitely it creates a lot of variation in age, and there are a lot of age nodes which basically are not helpful, right? But if we have age group as a node, then we can perform some analytics like what were the side effects developed under adults, what are the side effects developed under elderly, right? So that's why we have the age group as a separate node and not age as a separate node.
Mhm.
I hope I was able to answer the question. I
Yes,
mean,
I think
yeah.
that was great. I think that was a good explanation on that one. Let me quickly see if I see other questions that came up. Some specific ones that are. I think we have answered where specifically. I had one that was talking about if case ID is in all tables, how does this relate to the primary IDs in each table?
Okay.
You know?
If case ID is in all table, so does it relate to the primary ID in each table? Am I getting it right?
Mhm. Yeah.
Okay. So I'd like to show the data model over here. So you see the primary ID is present in all the tables, right? So the way FDA FAERS data model is like you start from the demographics. So this is basically a patient and it has a primary ID. And in case of drug also, it has the primary ID. So it has records like this patient has one drug A. This patient again has drug B, has drug C, has drug D. So there are multiple records for a particular patient in case of drug. So this is basically not exactly a primary ID in case of drug, but you can say this is a foreign key in case of a drug table, and it is mapping to the primary key of the demographic table. Similarly, in case of therapy, indication, reaction, outcome, and all. So basically, this is not a primary ID of this particular table. I was wrong if I mentioned it in that way when I was explaining the model. It was my bad. But this is basically a foreign key, and it is
Okay.
mapping to the primary key of the demographic table.
Mhm. Cool. And
Right.
then one question where a couple of people struggled was with the constraints and the indexes. So
Mm-hmm.
maybe if you could show this again and explain why did we set up the indexes and the constraints and what's the benefit of doing
Sure.
it.
Sure, I will do that. So I'll go to the constraint and indexes query that, for that. I'll just a bit, zoom in a bit. So you see
Mhm.
the constraint and indexes that we are setting here. So first I'll talk about the constraint. So constraint is basically uh, something that here we are doing to enforce the uniqueness of a particular property on a particular label. So when you see a
Mhm.
drug has a name as unique, so when we perform data ingestion, when we have a CSV file, it has a lot of drug entries, and the drug has all the drugs have their names. And if there are duplicate records inside the CSV file, and if we are making ingestion to the Neo4j, and we are writing a query using the merge statement, right? So if we are using merge, and when so I'll go to the query where we are ingesting the drugs, right? So we are using the merge statement, and we are saying merge drug and use the property name to identify the drug uniquely, right? So since we have the unique constraint on the drug, the Neo4j database ensures that there are no duplicate drug names present in the data that we have in Neo4j, right? And when we execute this query, when when we get a drug name from this CSV from a particular row, it matches the name with what all drugs available in the Neo4j and gets this exact drug. If it gets the drug, then it does not create it. If it does not get a drug with this particular name, then it creates a new drug. So basically, the uniqueness of the or the identifier is to perform the matching when we are executing the query. And also, uh, when we create a constraint, it automatically creates an index over that particular property. So it also gives us an advantage, like when we try to search for a particular drug using the drug name, then it gives us some performance advantage because we already have the index on the name property of the drug. So that is what we have. That is why we have the uh, constraint. Also, if you see, in case of case, we have the primary ID as a unique constraint, right? So when we perform the data ingestion to Neo4j, we want to make sure that we do not enter records with duplicate primary IDs, because if there are two patients with same primary IDs, then uh, the data is not consistent, right? We lose on the consistency part. And also, when we try to match a patient and try to link it with a drug that the patient consume, we find two patients in case of one patient. So that is why we have the constraint on the primary ID. And in case of index, so why we have indexes? So indexes are basically specifically for the query performance, when we want to fire some queries which are searching on property from the nodes. So in that case, we can have indexes. So indexes basically the properties which are indexed. So when the Neo4j query Cypher runtime executes the Cypher plan and tries to compile the Cypher query, it does not read through all the properties. If we are searching using the age property, it just goes directly to the age property and brings out the records using the given age that we have specified. So this is why we have indexes, and that's the difference between the index and the constraint. The constraint is basically to enforce the uniqueness, and the index is basically to improve the performance. And the constraints are by default having an index behind the scene.
Okay, cool. Thank you, Jintan. Uh, that's great. I think with that we can, uh, yeah, we can do the analysis.
All right. Okay. So we'll move to the analysis part. Uh, so we have loaded all the data. I am assuming you guys have loaded the data as well. If you are facing any issues, let us know. We'll try to help you guys. Going to the analytics part. So first is, what are the so now we have the data ingested, right? So we'll take some questions on the data, and we'll try to produce the results, right? So let's say, what are the top five side effects reported, right? So this is just a simple query. I'll just take the query and paste it here and then explain. So what we want here is top 5 side effects. So we want to show the reactions that is basically a side effect, and the case that has a reaction, and then we are returning the description of the reaction,
Can you
and then we
zoom
are
in
also
in the view a little bit so the query is a little bit better to read?
oh
Yeah,
sure.
perfect. Thank you. Cool.
Yeah. So this is the query. The case has a reaction and the reaction is R, and then we are returning the description of the reaction. We are also returning the count of reaction, and we are ordering it by count descending, so that it gives us the record in order of in descending order of the number of reactions. So the more number of the more the number of reactions, it will return us, right? So I'll again zoom out a bit and then execute the query. So you see these are the top 5 reactions that the patient develops. So fatigue, and then product dose omission issue. So as I mentioned earlier, it is not just about the adverse event, it is also about the fault in the device that is given along with the medicine. So this is such an example: product dose omission issue, and then headache, nausea, and pain. These are the side effects that the patient developed while they consume drugs. So these were the most common side effects reported in the FAERS database. What are the top 5 drugs reported with side effects, and get drugs along with their side effects, right? So I'll just take this query and paste it here. So we want top 5 drugs and their side effects, right? So we start with the case. So the case, and then we get only the primary suspects. So we only focus on the primary suspect drugs, and then we get the drugs. So the case, primary suspect drug, and then we match the case and say has a reaction, and then we get the drug name, d dot name as in drug name, and then collect the description of the reactions as side effects. So the collect is nothing but collecting various descriptions as a list, and it gives you a result in form of an array or a list, and then also counting the description as total side effects, and then returning the drug name and the side effects. And this is the syntax that you use to return the top 5 side effects. If there is if in the list of the side effects there are more than 5 side effects, then it will just show the top 5 side effects, and then it will also show the count of side effects that is the total side effects, and then we are ordering it by the total side effects or descending. So you see these are the drugs which are causing the side effects, and these are the side effects. So as I said, the side effects are returned in form of a comma separated list. So it is, if you connect your Neo4j and you connect using the Neo4j driver, and you read from your application using this cipher, then you get this as a list or an array, or I mean based on the language that you are using, an array list or a hash map or something, right? And these are the drugs which are causing the side effects. Going further, performing some data analytics on the companies. So what are the manufacturing companies which have the most drugs which reported side effects? So if I explain the query, we start with the manufacturer, and the manufacturer registers cases, and the cases have side effects. So you can see the simplicity of the cipher here. So if you would be doing this in an SQL query on a relational database, then you will have to join the demographic, the case table, the manufacturer table, and the reactions table, and then you will have to make sure that you group certain entities in order to produce the count of the side effects, and then you produce the result from those tables, right? So in case of cipher, it is pretty simple. It is just manufacturer, and you just need to uh, describe the way your entities or the nodes are linked. So manufacturer registered case, and the case has a reaction R, and the manufacturer name is a company, and then count of R is the number of side effects, and I'm ordering it by the number of side effects descending. So you can see that these are the companies whose drugs had the most side effects reported. So Takeda and the Pfizer and the Novartis and Roche and then AbbVie. These were the companies whose drugs had most side effects reported in the FAERS database, right? So this is how we can perform queries. Now going further, top 5 registered drugs and their side effects. So we want to know what are the drugs which had side effects. So what are the top 5 drugs which had side effects? And we are also adding one more condition here. So uh, we listed the top 5 the top 5 manufacturing companies who had most drugs which had side effects listed. So now we are taking one of the companies. So we are taking Novartis as from the list, and we are seeing what are the top 5 drugs from Novartis which had side effects registered in the fairs. So we start with manufacturer again, and we have a condition for identifying the manufacturer. So as we saw while creating the model schema, we created an index on the manufacturer name. So we are identifying manufacturer from the manufacturer name, and then saying manufacturer registered a case, and then the case had a reaction, and where the case had the reaction, and the primary suspect for the case was this drug D. So here I'm not specifying the label for the drug, because when we have the relationship type is primary suspect, it does not go to any other label rather than drug. When we have a relationship type of is primary suspect, then it always goes from the case to a drug. So that's why I don't need to specify the label type over here. It just takes the variable name and it gives me the reference of the variable if I do away with just the variable name. So I'm returning the drug name as drug, and then collecting the distinct R description. So R is the reaction here. So I am collecting the reaction description as a list, and I am counting the R as total reactions, and then returning the drug, and then 5 reactions out of whatever reactions we have for from those drugs, and then total number of reactions, and I am ordering by total number of reactions descending. So you can see that these are the drugs which had the most side effects, and these are all the drugs from the company Novartis. And then what are the side effects that these drugs have? So motor dysfunction, drug ineffective, multiple sclerosis, and these are the side effects that these drugs are having. So you can see the simplicity of the query, how I'm getting the drugs as well as the list of side effects, and I'm choosing the top 5 side effects from all the side effects the drugs are producing, right? So this is the simplicity of the query that we are performing when we are performing against a graph, right? Going next, so we are performing some analytics on the consumer report. So what are the top 5 drugs which are reported directly by the consumer? So the people like us who consume the drugs, and oh, we develop some side effects, so we report it to FDA so that the FDA takes some action on the drug, right? So this is the query. So we start with the case, and then we say reported by the report source. So I'm taking the RPSR as the reference for the report source, and then I'm giving the name of the report source as consumer. So the name property in the report source node is a unique constraint, and I can identify it by its name. And then I'm saying match case with the primary suspect, that is a drug, and then the case has a reaction R, and then the report source name as a reporter, D dot name, that is drug name, and then I'm collecting the side effects from the reaction description, and then I'm getting a count, and then I am returning the drug, the reporter, the side effects, the top 5 side effects basically, and ordering it by the total. So when I fire the query, it gives me these drugs were reported by directly consumers, and then these were having the side effects like injection site swelling, and then illness, off-label use, infusion related reaction, rash, and all those side effects were reported by consumers for these particular drugs, right? So this was the query for the consumer reported drug. Now we go ahead and see what are the top 5 drugs whose side effects resulted in death of the patients as an outcome, right? So now it's going a little becoming a little a little serious analytics. So I mean, what are the drugs whose consumption develops such a side effect in patients, so that the long term outcome of the same resulted in the death, right? So we have outcome label over here. So we are identifying the outcome by the name, the property of the outcome, that is outcome equal to death. And then we are going with C, case resulted in outcome. And then C has a primary suspect, that is a drug. And then C has a reaction, that is R. So initially the case developed some reactions, and then at the end, after some time, the outcome was death. So we are returning here. So we are returning the drug name, and we are collecting the side effects again, and then we are returning the outcome, and then we are taking the count of cases here. So the more number of cases, so we want to order the drugs in a number, so that the more number of cases were involved in the death as an outcome when those drugs were used. So we want to list drugs in that particular order. So we are listing the drug side effect, and then we are ordering by the number of cases who resulted in the death as an outcome. So when we fire this query, so you see these five drugs whose side effects started with these side effects, like white blood cell decreased and fall and chills and prexia and all. And for all this, the final outcome was death. And the number of cases were 24, 18, 13, 11, and 9. So these were the drugs which had so serious side effects, so that the patient down the line resulted in the death. So the that was some analytic we performed on the outcome based resulting, right? Now going further, we perform some data analytics on the drug combination and the case details, right? So now it's going a little interesting, like this is the first query. As you read, show the top 10 combinations which have the most side effects when consumed together, right? So you can imagine that if you are having your data in a relational database and you want to produce some output like this, that what are the top 10 drug combinations when they are consumed together, they developed side effects, they develop more side effects, right? So uh, how complex it can be in case of an rdbms to produce a result like this, like. But in case of Cypher, you see that we have a few lines of Cypher, and that too, getting the data out of the graph was so simple, but it is just that the collecting information in a way that it is presentable. That's why the query is a little long. So we are starting with the case, and then the primary suspect and the secondary suspect. So basically, when we talk about the combination, so there is a primary drug and there is a secondary drug. So we are taking this primary and secondary suspect in picture. We are not taking the concomitant and the interacting drug as of now. And then we are saying the case has reaction R, and then the case resulted in outcome O. As I said, I don't need to mention the label here, because the case resulted in relationships only goes to the outcome nodes. And I'm saying where D1 is not equal to D2. So when the drugs are different, so the drugs should not be same, because uh, we want to return the pair of drugs when taken together, consumed together, they develop side effects, right? And then we are saying we return us the drug name, and then primary drug, secondary drug, and then the side effects. Again, we are collecting the side effects, and then taking count of the side effects, and taking count of the outcome. And then we are returning primary drug, secondary drug, side effects. So three side effects from the list, total count of side effects, the first outcome from the outcomes list, and we are ordering it by the number of side effects, and we are returning the top 10 records from the query. So you can see that I can zoom out a bit so that it fits in my screen. You can see that these are the drug combinations. So primary drug and secondary drug. So you can see this these two drugs when taken together develops fatigue, pneumonia, neutrophil count decreased, and then down the line it resulted in hospitalization, initial or prolonged, right? These two drugs, when taken together, they develop side effect like these many side effects, and then it resulted in disability of the patient. And the total side effects developed when these two drugs were taken in combination were 222, right? So this is how we can get data out of the graph database, which is, I would say, so complex in case of the relational database, right? Now we move ahead and we take one of the case, and then we list all the demographics, all the drugs given, side effects and outcome for the patient, right? So the query that I mentioned to you when I was asking you why we are using a graph database solution for this RDBMS problem. So this is the same query that uh, we were trying to imagine that we if you want to write it in SQL, how complex it could be. So in case of Neo4j, in case of Cypher, you can see the query that it is simple and self-explanatory, that the case with a primary ID, this consumed a drug. So now I have put this relationship type as consumed. So I'm not using the specific type like the primary suspect or a secondary suspect or concomitant, because I want all the relationship types which are between the patient, the case, and the drug, irrespective of their types. And then I want the outcome. So the case resulted in outcome, and then the case has a reaction. And then I also want the therapy, like the therapy that was prescribed, that prescribes the drug. And here you can see the relationship direction is not specified because it is implied, because we only have the relationship going from a therapy to a drug, that the drug prescribed the therapy prescribed the drug, I'm sorry. So this is why I'm not specifying the direction here. uh, and I'm saying the distinct age and age unit, because we are also having the age and age unit like the year and months and whatnot, right? So the age like 53, and then year it will concatenate, and then gender, and then I'm collecting the side effects again, and then I'm collecting this information, like I'm collecting a distinct of drug name and the dosage, like the consumed dose amount and the consumed dose unit. So you see these things are coming from the relationship. So the consumed is the relationship identifier, the relationship reference that we have specified over here, and I'm saying consumed dot dose amount. So in the relationship we have a property of dose amount and dose unit. So these things are coming from the relationship. Indication is coming from the consumed property, and the route, that what was the route of the medicine, how the medicine was taken, was it an oral or was it an intravenous, or what are the types, right? And then I'm collecting the outcomes, and I'm returning the age, gender, and treatment. So this thing I am calling as a treatment, like we have aliases for the columns in SQL. I'm calling this as a treatment. I'm returning the treatment. I'm returning side effect and the outcomes. And when I execute this query, you can see that it shows you the details, like the age of the patient was 67 year, and it also included the unit 67 year, and it is the patient is a male patient. What was the treatment? So this was the 300 mg, route is unknown, the indication is unknown. This allopurinol drug was given. This 100 mg drug, the indication was pain, and to subside pain the drug trazodone was given, and this is the another drug. So these are the drugs which were given to the patient, and it also contains the dose, the route, and the indication, and the drug name. So this is the treatment which is given to the patient. So it contains all the drugs in form of a list, right? This is a list. We are just seeing a scroll bar because the list has too much information to show. And then you can see the side effects that the treatment developed. The patient developed these many side effects, and it resulted in hospitalization, initial or prolonged, and other serious. important medical event, right? So these were the outcomes of this particular case. So we are returning all these details around a particular demographic, a particular case, the treatment that was given, the drugs, the amount of drugs, why the drugs were given, what were the side effects developed in the patient when the patient was given these many drugs as a treatment, and what was the outcome, right? So that was the result of our query. Now, coming to the age group based analytics. So I we got some questions like why the age or age group was taken as and created as a separate node. So this is a query which maybe explain it. So I'll just get this query here, and it is, what is the age group which reported the highest side effect and what are those side effects, right? So we are starting here with the age group, and then we are saying age group and the cases those fall under these particular age groups, and then the cases has reaction R. So we are matching age group first, and then we are linking the cases, and from the cases we are going to the reactions, and then we are saying, okay, return, give me with A, and the collect all the descriptions, so collect all the side effects, count of side effects as total side effects, and then return me the age group as age group name, and then return me the side effects. The first six side effects from the list, I mean, from n number of side effects you get for the particular age group, you return me the six side effects, and order by the total side effects descending. So the more the side effects, the age group will be written on top. So you can see that the adult age group has the most number of side effects which were reported in the FAERS database from the US region. So I mean, I'll remind you that the data that we have ingested, it only contains the demographic from the US region. We have cleaned the data and filtered the other countries' data so that the example becomes fast and simple. So these are the side effects reported in the adult age group, and adult was the age group which had reported the most side effect. What are the highest side effects reported in children, and what are the drugs those cause these side effects, right? So I'll just have this query here, and I'll start with the age group again. I'll identify the age group. I want the side effects in the children. So the children, and then the cases falling under the age group. So case falls under age group, and then I'm matching the reactions, and then I'm getting the primary suspect because this time we want the drugs as well, right? And then we get we get the reaction description, and then we collect the drug name. So we also collect the names of the drugs as a list, because against the age group we want the number of reactions, we want the number of drugs, and then we want to list against the age group, right? So we return the side effect, we return the drugs, right? So here, if I execute the query, you see the children age group, the child age group has the side effects pyrexia, the drug dose omission by device, and the dehydration, vomiting, and product dose omission issue. Right. So these are the side effects, and these are the drugs which were involved in these side effects. So we are now currently focusing only on the child age group, and the side effects and the drugs which are causing the side effects. So we are producing this result from this query. Now, what is the percentage wise allocation of side effects for each age group, right? So the age group and the percentage of side effects out of the total side effects reported, age we want the age group wise bifurcation in form of percentage, right? So we start from the case has reaction, and then we get the total reaction. So we get the total reactions count because we want to produce the percentage, so we want the total number, and then we match the age group, and then we say falls under the so the C case falls under age group, and the case has reaction R, and then we say with A we take account of the age group wise reactions, because here when we match the age group and case and the reaction, we get the age group wise reaction. So we have the total reaction, and we have the count of R, that is the age group wise reaction, and then we return the age group, we return the age group name from it, and then we divide the age group wise reaction by the total reaction and multiply it by 100 in order to get the percentage. And then we execute the query, and it says the adult has the most number of reaction, that is the 49%. Elderly has the second number, so that is 41, and so on. So the infants has the least number of reactions reported in the database, in the FAERS database, right? So this is how we can perform some querying. So I hope I was able to explain the queries. I was able to explain how we can produce the right amount of the right results out of the graph database, and how writing ciphers and producing results out of the graph database can be much simpler than getting the results out of a RDBMS, right? So we'll move on to the Bloom part, but I'll take a couple of minutes break. I would first ask Alex, are there any questions, or are there any? I mean, is everyone okay? Is anyone facing any difficulty?
Thank you, Chintan. I think there's great variety of queries you just showed us. So I think that's was really powerful to see. Okay, all this different the different questions you can ask from this model, and how to find out, side effects, age groups, and filtering by side effects, or filtering by outcome, filtering by medicine, filtering by manufacturer. So it's a huge it's very powerful, and I think it's very, very insightful to see. So we have a few more minutes left. So I think we probably want to continue. But one thing that came up a couple of times, could be something you can explain a little bit if you have the time, is why you sometimes don't need to specify a direction. So we have the model, and we have specified direction to the outgoing relationships or the incoming relationships, but sometimes it's not necessary.
Yeah.
So why is that? And yeah, why do we do this in some of the queries?
Sure. So I will take this model. You are seeing my screen, right? Okay, yeah. So
Yes.
I'll take this model as a reference to answer this. So why we why we don't specify the relationship type or direction when we are executing some cipher queries in order to get some result out of the graph database, right? So if I give you an example of a case and a company. So if you want to if let's say if you want to produce a data that give me a list of companies and the cases, those who are registered by that particular company, right? So I want the manufacturer and I want the case. So now I go ahead and write a query like match C, that is a case, and then I'll say registered, and then I'll say manufacturer, and then I'll say return C, and I'll give this a name M, and I'll say return C and M, and it will return me. Okay, I did not specify the limit, but let me specify the limit. So it will return me, let's say, one company and 5 cases which are registered by this company, right? Now, you can see in the model that the registered relationship is only between the case and the manufacturer, right? And it goes from the manufacturer towards the case. So in the Neo4j, if we have the relationship that is only present between two nodes and the direction is always specific, right? It does not have the relationship, the registered relationship is not repeated in any other edges, right? And it also has one I mean, it has only one instance, and it also only has one direction. So if I don't specify a direction over here, it understands that it definitely goes from manufacturer to case, because we only have one type of registered relationship, and that is also having only one direction. So that's why if we don't specify a direction, it is good. If we specify a direction, then also it returns the same results. If we don't specify, then also it returns the same result. Now if we don't specify the type, let's say I don't specify the type, I say reg, and then I leave it. I leave the relationship type without relationship type, right? But the Neo4j compiler knows that when it is between the case and the manufacturer, there is always one relationship. We don't have any other relationship between the case and the manufacturer, so it automatically takes the same relationship registered, right? So this is how we don't specify the direction sometimes, because we know that there is only one direction going from manufacturer to case, it's not the opposite. And we also don't specify the relationship type name sometimes, because we know there is only one relationship going from the manufacturer to case. And same in case of the labels. I mean, so let's say we have the relationship type specified here, so we have the registered specified over here, but let's say we we know that when it is registered, then this side it's a case and this side is the manufacturer. So if we don't specify this, then also it returns the same kind of results, a little bit deviated, but yeah, I mean, it says the same thing, because uh, right, it returned a little different result than the previous query, but it returned the same kind of result, like Pfizer and the case, again on the case, and GlaxoSmithKline and the case. So it understands it. So that's why we don't specify labels sometimes, because we understand we have only a particular type of label or a relationship type or a description for that particular two entities, right? I hope that was
Yeah.
good.
Super. Yes, I think that explains it, and that's especially for for the beginning. It's very helpful that if you know how your model looks like, you can sometimes take the shorter path,
Yeah,
literally,
correct. Yeah, so
and
it is
cut some
basically the
corners.
simplicity of Cypher that the Neo4j Cypher
Exactly.
offers, right? You can
Yeah.
avoid writing all the types and variables, because you know that there's nothing else gonna be there.
Yeah. Yeah.
All right.
Cool.
Okay,
Thank you.
so thanks, Alex. And so now we'll move to the exploration session, that is the data visualization part. So we'll go and we'll click on the explore button that opens up the Neo4j Bloom. And if you guys are using the Neo4j sandbox, then you can click on this arrow and then you can say open with Bloom. So that will open Neo4j Bloom for you for that particular sandbox. And when you see the Bloom, so it gives you a prompt to enter the username and password. So I'm using the username will be the Neo4j by default, because it's Neo4j always. And then I use the password that I downloaded from the console when I created my instance. So I'm logging into Bloom. So this is how you log into Bloom. Now, okay, so in order to go and start using Bloom, we first need to download a perspective. So it gives you with a default perspective, but we will use a specific perspective that we have developed for exploration. So we will go to this URL, the I'm sorry, we'll go to the base of the GitHub repo that we have shared with you, and in that we have a Bloom folder. So you go to the Bloom folder. I'll again mention that we are in the same repo. We just went to the top, the parent of the repo, and then we go to the Bloom folder, and here we have the healthcare analytics perspective.json. So it's a JSON file, and you need to click on the raw, and then you need to save your file using the save as. So you will be able to download this healthcare analytics perspective. So once you download the perspective, you go to Neo4j Bloom, and then you say import perspective, and then you see the perspective that I downloaded. It's a JSON file, and then I open the perspective. It gives me a perspective. It has 8 categories, 8 relationship types. It shows me the labels that I have in my database, and when I click it, it loads the perspective for me. Okay, so this is the Neo4j Bloom screen, and here you can see the age group, case, drug, manufacturer, outcome, reaction, report source, and therapy. These are all the nodes. These are all the relationships. So the relationships also have the names, and we can choose, let's say, different colors for the relationships also. Like we choose red for the primary suspect, and we choose little bit of orange for the secondary suspect, right? And then So this is how we can configure. There are a lot of configuration options. I'm not going into all of those things right now because it will be a separate session altogether. But we must be having some training sessions. I remember Priya had some training session on the Bloom capabilities, and you can go through that session to explore the Bloom capabilities. So yeah, this is what we have in Bloom, and I'll just show how we can uh, use Bloom as a data visualization tool to showcase some analytics queries using the graph visualization platform. Maybe you want to have some presentation in front of your leadership to showcase some example that you have developed in the Neo4j graph database, and you want to demonstrate them with the graphical visualization capabilities. So you must use Bloom in that case. So I'll just show how we can explore data in Bloom. So yeah, let's say we have manufacturer, and then we can say manufacturer. We can find the manufacturer by name, and then we can say, and it will give you the manufacturer no artist, and then you can right click on it, and then you can say expand, and then it gives you what all cases. So we have the manufacturer registered cases in our model, right? So it shows you the relationship, like what all cases are registered by Novartis. So you click here, and it will expand the cases that were registered by Novartis, and you see all those cases have the information like the male, female, and if you double click on a case, you can see the age unit, the event date, gender, primary ID. So all these are properties of the case. So you can explore this in a simple fashion and in a rich interface, right? If you click on this case, let's say, and then you say, I want to see what all reactions this case developed. So you just see it gives you this reaction nodes, and I'll just zoom in a bit for you. So you see platelet count decreased, and the other reaction that the case developed, right? Similarly, you can expand on some other relationships like falls under what age group, what was the outcome, what was the drug that developed this side effect for this case, right? I'll just clear the scene, and I'll show you how we can execute some more natural language processing like queries using Neo4j. So I have developed some predefined phrases. So you can see here, I went to this perspective, and I went to the saved cipher. And in the saved cipher, you see the scene actions, and you see the search phrases. So I'm currently in the search phrases, and you see I have added two search phrases. So you can click on add search phrase, and you can add a search phrase. I'll show you what I have added so far, and you will also see it if you have loaded the same Neo4j perspective JSON into the Neo4j Bloom. You will see the same screen. So you see drug links with drugs linked with side effects in the age group. So you see the drug linked with side effect in the age group. So this is a plain text I have written, and this is a parameter of the age group, and I'm providing a description that list the drugs which are linked to the side effects in a selected age group, and I'm here specifying the age group as a parameter. And this is the cipher query which I'm executing when someone asks a question like this. I hope the screen is visible. I'll zoom in a bit so that it is visible to you guys. So I am having this search phrase. This is a parameter, and this is a cipher. So I'm starting from the age group, and I'm using this parameter over here, and then I'm saying this is falling under. So the case falls under this age group with this particular name. Case has a reaction this. Case as a primary suspect, which is a drug. Again, I'm not specifying the drug label because I know that the primary suspect goes from the case to drug only, and I'm returning the 25 drugs out of what all drugs which have caused side effect on this particular age group, right? And here I have specified that the parameter age group is of type string, and when the user will perform this parameterized query, the Bloom will provide some suggestions. So what suggestions the user will get? So it will get the user will get the suggestions for the age group names from the age group node. So here you see the age group node, and the age group has a age group property. So the user will get the age group name as a search suggestion, like child or infant or elderly or adult, right? So this is how I have saved a search phrase. And now if I go here and I click here, it shows me the search phrases that I saved. So drugs linked with side effects in age group, and then it gives me a suggestion like what age group you want to have your query. So I say, okay, I want to have the drugs linked with side effects in the age group adult, and then I just say enter, and it gives me the top 10 drugs which caused side effect in the age group adult, right? So this is how easy it is with with Neo4j Bloom to define some business questions and parameterized question, and then execute some Neo4j queries against your questions with some parameters and showcase the graph results and the analytical queries in form of the graph data visualization, right? I'll go to the other query that I have. So explore adverse event case with case ID this. So I want to explore a case like what all treatment, what all what is the therapy given to the case, and what are the drugs involved, and what was the uh, what was the company, and what was the reaction, and everything regarding a particular case. So what I'll do is uh, I just need to click here and then say explore adverse event case with case ID, and then I'll just use some case ID here, and I'll say enter. So it will give me the whole detail of a particular case. So if you remember again, when we were trying to imagine the SQL query which is required to get all these details, how complex or complicated it can be, and in case of Cypher, how easy it is for us to produce all the details. Like this was the case of a male, and it was reported by it was registered by Clegane, and then it was reported by healthcare professional, and the person developed this reaction, and he was an elderly patient, and then he was having these drugs. Like primary suspect was this drug, and then secondary, and one more secondary, and this was the therapy which was given. And if you click here, like this was the drug which was primary suspect. If I double click on this, so you see the dose amount, the dose unit, the indication why the drug was prescribed, the plasma cell melanoma was there, and the route was oral, right? And the dose amount was 25 mg. So all the details are we are getting using this simple Cypher query. This is of a few lines, right? And we are returning all the details, and we are returning all the details, and we are showing the details in form of a graph visualization. So this is how you can use the visualization capability of the Neo4j Bloom when you develop an example use case and you want to present something to your leadership or some circle. It's a very good tool, and it can come handy to you. So yeah, that was the Bloom exploration part. I hope I was able to explain you in an easy way, and you were able to get the most out of the session. I would say thank you everyone for your time. That was everything I had for the day. Thank you so much for your patience, for listening to me for for a couple of hours. And please reach out. Please reach out in case you have any specific questions. I'll be happy to answer. You can reach out to me on my LinkedIn. That is Chintan Desai 7, and you can also follow me on my Medium page. I will be throwing some articles on top of, I mean, using Neo4j and things around Neo4j because of my love for Neo4j and some other technologies that I know of. And again, thank you so much. Have a good day or good night based on wherever you are. All right, over to you, Alex.
Thank you, Chintan. Can you one more time show how to get to Bloom from your Aura instance view?
All right.
Exactly
So
from there. Yes.
So this is the Aura DB console, and I just need to click on Explore. It opens the Neo4j Bloom window for me, and it asks for the
Exactly.
username and password. So you need to enter Neo4j as a username, and then you need to enter the password that you downloaded or copied when you created the instance.
Cool.
So this
Perfect.
is
Thank
the
you very
button.
much.
Yep.
Yeah, exactly. Yeah, that was a short confusion here. So yeah, cool. Thank you very much. Thank you, Chintan. This was great for showing us not only some queries in ORDB with Cypher, but also visualizing some of the results back in Bloom. Particularly the last one, it was very powerful query, one stop shop basically for everybody that doesn't need to write any Cypher code. You can prepare this for everybody and said, okay, just enter the case ID and you get the overview of the patient journey basically up to where they are now. So this is, I think, very powerful, and it shows the beauty of the graph and the flexibilities and the capabilities. So yeah. Thank you very much for joining. Thank you again, Chintan. Thank you, Alexander, on chat for helping with the questions. It was very active, very intense. So very good to see that happening. The slides, the links, and the video recording I will share with you tomorrow. So you will have the chance to look at that again in the future and have maybe if you want to replay some stuff, you can do it from the video recording tomorrow. If you are interested in doing more workshops, we have 3 more planned over the next couple of weeks. So you can go to our Neo4j/events page and look at the upcoming sessions. I post a couple of links in chat now, and you go there. Don't forget the Graph Academy is also a great place to start learning. So if you are a beginner and want to learn more and want to try some courses, go to the Graph Academy page. There are lots of different sessions on importing, but also more advanced Java development courses, for example, and some on graph data science. Don't forget to register for notes. I hope to see you there. Yeah, and with that, I think we're done. Thank you again, Chintan. Thank you, Alex and chat. Thank you all for watching. It was a pleasure. It was good fun. And I hope to see you again soon at another workshop or another live stream. Take care, everybody. Bye.
Thank you so much, everyone. Bye bye. Have a nice day.